Hello, everybody. My name is Viktor Korsun. I'm working for STL. Currently, I'm a head of client-side development. We create computer games, and I'll be talking about enhancing STL containers. Actually, I'm surprised that at least somebody has come here because it's widely believed that standard template library containers are absolutely polished and they are ideal. But I think that there are some signs of that developers need some more. For example, our company is always implementing our own containers constantly. If we take a look at any big project, we can see that many companies implement their own solutions. And all we must have got a USB drive with a flash drive with a library, and inside this library there is own implementation of containers too. So people implement containers, and why? Why do they do it? Who try to implement their own container in their programs? You see, almost everybody. Why didn't you like standard template library containers? For example, for instance. Yes?
I do like them, but I needed something with characteristics different than any of them.
What did you need?
I have basically a pair of integer, a range and a value.
Yes.
I want, when I insert something with an overlapping range, the last writer always wins. It's kind of like a set, but it's ranges with values, so it's
yeah. Could you get this behavior if you overrided some functions?
I layered over an STL container.
Yeah. I think that standard library containers are great, really, and they are good enough for many situations. But sometimes we face situations when we need something more. And sometimes also happens that we misuse standard template library containers. So here I would like to show a few quotes from interview of Alex Stepanov, initially author of STL. And then I will speak further. Alex Stepanov said that standard template library isn't object-oriented. And after that, he says that object-oriented development isn't that good. And if we dig into details, we can see his strong attitude towards this. So there are two general ways to design a program. The first one is object-oriented design, and the second one is a generic programming. And in our company, we create computer games. So here is a screenshot. And what we can see is greatly decomposed into objects. Because objects have similar features, similar behavior, and generally the program should be object-oriented. And everything here is an object, obviously. And object-oriented development bases on these principles. Let's take a look if standard template library containers satisfy these principles. What's about abstractions? Are they abstract? Yes. What's about encapsulation? Yes, they do. What's about inheritance?
Some of them internally.
Yeah, but generally not. Generally, they don't have virtual destructors.
Oh,
And that's why polymorphism is only compile time. And what's about elements for containers? Is it possible to implement abstraction on them? No. It's possible to implement encapsulation definitely, inheritance through pointers, and polymorphism through pointers, but not directly. Either raw pointers or smart pointers, never mind. So, as object-oriented developers, what we need? We need just to insert an object into a container, to address it, to work with it, obviously to remove an object, and ideally we want polymorphism out of the box. I mean, not through smart pointers, not through double storing of something and addressing through raw pointers and whatever. And that's why we want to support polymorphism out of the container. So, as I think, an ideal syntax, as for me, would be like that. We define class A, class B, and create parameterized container, and add these objects. Is it possible with C++? Any ideas how to implement that?
Boost pointer container?
I'm sorry?
Boost pointer container?
Well, we don't work with pointers here.
Pointers are prohibited, right?
Yeah.
For this game.
Yeah, because if we have a pointer, then we have to store this object somewhere. And how we can expand or shrink this container dynamically?
How can you achieve polymorphism without pointers?
That's a point. But we could achieve a polymorphism without pointers through a reference to base class. And if we return object B by index, we could return a reference to object A. So it is possible. I won't dig into details, but I will briefly just explain one of the possible implementation how to do it. We can implement a template method pushback, allocate memory, and then add this object, obviously. But the interesting point is how to access the object and how to resolve the type without runtime type information. It is possible if we created an additional storage of accessors, and while we add an object into this container, we would add a getter for this object. So at the moment of addition, we know a type of the object. That's why later we can get this type in runtime. So this syntax is possible. And in the model that I'll show later, I'll explain how to do it. But what we don't need is to rely on objects layout and memory because, well, we must to decide either we do generic programming or we do object-oriented programming. If we do object-oriented development, then we don't need to know where the object is in memory because what we need is only to access it, to modify, and we rely on abstractions. We rely on interfaces for objects. That's why the container ideally has to decide by itself how to store them. So here is how many programs use a regular vector. It has objects inside that are boxes here. It has iterators that point to these objects. And free store, by free store I mean an allocated store for following objects inside the vector. So this is how basically many programs use containers. In more than 50%, I'm sure. because we need to store similar entities and access and change them and swap them. And we can use it in our game, for example. So what we do here is we create a lot of animations, a lot of objects, and then we have to swap them, change their order. And here arises a problem. Because when we change the order of objects in vector, for example, if we sort objects in vector, as you could read from the description to this meeting, the complexity algorithmically should be n multiplied by logarithm n in big O notation, right? But that's not true, because this complexity multiplies by the size of the object. Because when we sort objects, we not only change their indexes, but also we change their location in memory. But as object-oriented developers, we don't have to change objects in memory. We simply don't have to do it. If Vector wants it, well, let him, but we just didn't ask that. That's extra computations. So if we create a vector of objects and then sort them by any predicate, we'll lose performance. Is it clear for everybody? Yeah. Who doesn't tell why? Okay. And a possible implementation of a more effective solution is usage of pointers. So pointer obviously consumes less memory than a usual object. And while we change their order, byte swapping in memory occurs less. But there is a problem here. The problem is that we have to start these objects and have to maintain their lifetime. So if we create some container, like game container, probably a character, and we add a head, a gun, something inside it, we create a vector of pointers to these objects. This would work, but if we want to create these objects dynamically, this won't work, because we have to store these objects somewhere. And the solution of this is what? How to control lifetime automatically of these objects. Any ideas?
Pointers.
Of course.
Reference counting.
Smart pointers, surely. Yeah. This works almost as we want, except one thing. And the thing is that if we take a look at the position of objects in memory that I shown, like not in a realistic way, but it reflects the situation. We can see that these objects are located somewhere in memory. And when we address these objects, very often, we miss these objects in processor cache. So these objects not necessarily get into a cache line, because we can't guarantee where these objects are. Surely on this machine, for example, with enough memory, this will happen not that often, because usually allocations will be adjusted to each other. But that's not guaranteed. And the solution could be either our own memory manager for this collection, or for the whole application. But we don't need it. What we need is a simple collection of objects, and we want to address them and work with them in a dynamical and polymorphic way. So this works, but this is not ideal. And I suggest this thing. I suggest storing objects internally and storing indexes of these objects internally. So when we address an object, we resolve its address inside a container and then address it. But if we want to swap these objects, what we do is swap indexes. This should work much faster. And it does. Any questions about that? That's a simple idea. But what we also want is to support like the knowledge of C++ society. I mean, use libraries like algorithm for that. So if we want to do something like sort or reverse, we have to implement iterators. And as we have an extra layer under our objects, we will be having to implement an extra layer on like regular iterators, like that. So it will look like following. Our iterators show two indexes of the objects. And after dereferencing these iterators, we have some wrappers that can give us an access to objects. Because by dereferencing iterators, we will be having an internal offset, so that it would be possible to swap these iterators, and by swapping iterators, we would be swapping indexes rather than objects in the storage. Provided that, algorithm functions will be working like we expect them to do. So standard sort will be fast, reverse will be fast, and what we want. Actually, we can even work with iterators directly. And here is a short demo. I'll try to duplicate these displays. Yep. Okay. Not that good. Let's give it a try. Oh, it's better. So, the best way to demonstrate an idea is to create a synthetic test. And I did that. I created an object T. Actually, it's a structure with 10 kilobytes, not 16 and 4 zeros bytes of memory. And here's a predicate for comparison, and here is a vector of these objects. So what I do here is reverse this vector, then sort it using this predicate, and do it 10 times. And the length of the vector is like 10,000 elements. So let's start. Compiling. Test started. I wrote test started to make it obvious that the program is working because it works not very fast. Actually, it took almost 40 seconds to do these computations. So I don't know what to do these 40 seconds. But let's stare at the screen.
Can you scroll your code?
Yeah. I'm sorry?
So there's debug.
Yeah, it's debug mode. But in release mode, it's not much faster. The code is pretty simple. The most complicated thing is to measure time using modern C++. Wow, it has finished, so it has taken 56 seconds.
So the question is, which piece was the slowest?
I'm sorry.
Which piece in the code was the slowest?
Which piece of the code was the slowest one, right? I not only think, but I'm much sure that this one. So if I comment these 2 lines about reverse and sorting, we'll be working much faster. Let's give it a try. Four milliseconds. So now, what I want to do is to substitute vector with my O vector that is meant to be object vector. It's not parameterized because it's in development state, and I include after definition of the structure T because later it will be parameterized, but now it's easy to debug, obviously, while it's not. And all the other code will be the same, except the predicate. Who can me tell why the predicate is different? Predicate is different because our iterators, after dereferencing, return not value, but a iterator wrapper for getting value. So I call it subiterator, and after dereferencing this subiterator, we eventually get our value. And let's start it.
Yeah, but you commented out the reverse.
Yeah, thank you. Is it good? Okay. So I'm crossing my fingers again. Well, as we can see, it's almost 50 times faster. And if we can check it, what's going on inside, but I promise that everything is honest. I'll show the implementation of this class now. So the most interesting thing is implementation of standard swap function that is specialized by sub-iterator. As usual, we create a position temporarily, then we store it, and then we change indexes using these super iterators. Also, we define standard operators for iterators to make algorithm working. The same logics for iterators. And here's the implementation of this library. I wanted to show how to change elements by iterators, but I'm afraid we can't get it in time. So after presentation, who will be interested? You may ask me directly. And now I'll show you a few slides. So here's another question and answer for Alex Stepanov. And he told that generic programming is good and object-oriented isn't. But I think that object-oriented library for objects shall be designed in object-oriented manner, like having regular virtual destructor, like having virtual operators to give us opportunity to override them. And also, it must be having a regular object-oriented syntax rather than global functions. Because I don't think that working with object-orientedness in generic way a good idea. And here is an example of, like, it's a short quiz. Which code will be faster? This is the first one. This is the second one. So what we have here is a set of strings, and then we just look for a specific string in this set. And we don't even compare a result with something. So the question, what will be faster? The first one, it's like Alex Stepanov suggested, use a global function. And the second one is a object-oriented one. What is faster? There are obviously four answers. The first one is the first example is faster, the second one is the second example is faster. The third answer is they are the same. And fourth answer is there is no answer.
So what's the second one?
Surely. Yeah, second is faster because for the first one, we do a regular search like with random access iterators, but we don't use benefits of this data structure. So I strongly believe that an interface for object-oriented library, for object-oriented container should be object-oriented and without generic elements. And this means that we won't have to use algorithms. And this implies that we don't have to implement iterators. So an ideal object-oriented library, as I believe, is a library with object-oriented syntax. And as I said, we don't have to rely on objects location in memory about like the adjacency, because the object-oriented vector should store it by itself. And the quiz is how to make the code faster. What's happening here is filling an array of characters, and we want the final code to do the same, but be a little bit faster.
Well,
How to do it faster?
oh, you didn't tell us anything about Fibonacci function.
Yeah,
is
but
it implemented? How do we know that? How efficient is it?
Yeah,
You didn't tell us anything.
yeah, it doesn't matter because
It doesn't.
we don't have ability to change Fibonacci function. It's inside SAM library. And what we can do with it is like to improve the efficiency of this code. What I mean by this is that even regular arrays can be faster in C++. If we don't rely on adjacency of elements in memory. So it can be faster if we use alignment. Because addressing every single character will be faster without additional machine instructions. And here, I have to switch displays again. Okay. So that's the code, how it could be, and a few tests for this code. If we align characters with 4 characters in memory, obviously compiler will generate less instructions. And here's the output. So we can see that in the second case there is a 1 instruction less. And this will reflect in tests. The second example will be working approximately 20% faster.
You access 4 times as much memory.
Yeah, that's true. But actually, we do mobile games, and in mobile games, performance of every frame is much more expensive rather than memory. Because, well, most of memory in our programs resources consumed, and logic consumes much less resources. For example, if we have 50 megabytes of data, of textures and sounds, then only 50 kilobytes of data. Well, it will be not 50, but 60 or 70, or even 200. So I shown this example to say that if we don't rely on objects location in memory, that vector does, then we can get additional benefits from almost everywhere, from getting indexes, from storing objects using better alignment, and so on. And we have some time. I could answer some questions if they are. Yes? Yes.
Basically, what I would suggest is to define overload for applying different types of container. Therefore, you can choose what's the best way how to find an element of a container.
Yeah.
So it's more like current STL approach, right?
Yeah. The suggestion was to instantiate a find function for every container so that the function will be instantiated with the most efficient one. And this will be more in terms of current STL library with modern standard.
That's the same as using set find.
Yeah, it is, but it's essentially because use that in templates if you don't want to work with characters. So you pass like this and you don't just find it. You don't care how which range you know?
So obviously, a good implementation of object-oriented library is a big way. So to make this library supported by every compiler, it should be like done a lot of work. And yesterday, surprisingly, we implemented a very good solution, a best solution for C++ properties on workshop. So I couldn't find something more efficient on the internet comparing to our solution. And I think that it's possible to implement a good object-oriented library for like containers that will be used by object-oriented developers. And I hope that the amount of in-house implementations of containers will be decreased. So here's my email, and I'm going to start this project. And if you want to participate, please write. And we obviously will do a great thing. That's it. Thank you.